Welcome to this channel, and here we are about to find some answer. The question is what is the potential difference between the points A and B in the given figure? Well, the figure is already written here on the board, and we have to find the potential difference between the terminals A and B. In this picture, otherwise in this question, I am going to show you two different methods. One is Kirchhoff loop rule and the other is Thevenin theorem. And now I am going to show you how it can be solved easily. Well, in first method, I am calling it a Kirchhoff loop rule. Okay, so in this method, we have to choose the currents in the circuit like this. The first source of the battery, so which is giving a current I1 like this, and the second battery is giving the current like this, which is calling I2, and the two currents I1 and I2 meet at point A. So as a result, they move in the resistance 2 ohm as total, that is I1 plus I2. Okay, for this we have to consider two loops. One loop is on your left side and another one is on the right side. In the left side, I have to consider the loop in counterclockwise direction, and in the right loop, I am considering the clock counterclockwise direction. Okay, so now my reference point should be chosen. Here is my reference point for the first loop. The direction of the current in which I am considering the loop is taken positive. Okay, the current is also moving up as my consideration. So that means it is a plus, okay, so plus 4I1. This is how we have to write. Plus because the current and U both are moving in same direction. Otherwise you have to choose negative. Okay, so there is no resistor in this branch, and come to this branch. Here the current is moving down and U also moving down. So that means it is plus 2 times I1 plus I2, and there is no more resistor, and we reached the reference point one more time. So that is equal to sum of the EMF in the same loop, but I am having only one source of EMF. This is a 28 volt source. Okay, so this is from lower to higher potential, so it is plus 28. So just on solving this, I may get 6I1, right, plus 2I2 is equals 28. Well, this is the result what I obtained for the first loop, and I am doing the same for the second one, and my reference point is here. The current is I2, and from here to upward I have to go. So in the same direction the current is also moving, right? So that is, it is plus 1 times I2, 1 ohm into I2, and nothing is here. Okay, so come in this branch, when I reach this branch, the current is moving downward as before. It is plus 2 times I1 plus I2, which is equals, there is no more resistor here, and here also it is from lower potential to higher potential, it is plus 7. So on solving, it is 2 times I1 plus 3 times I2 is equals to 7. I am calling this equation 2, but where is equation 1? So from this, what I do is I simply solve this one to get 3. Okay, so it is divide by 2 and multiply by 3. Okay, when I do that, it is 3 times, and division, it becomes 3. 3 into 3 is 9. 9 times I1 plus, I divide it by 2, it is 1, into 3, it is 3 times I2, which is equals 28 divided by 2 is 14. 14 multiplied by 3 is 42. This is the first equation. Well, so now subtract equations. Okay, subtract equation 1 and 2 like this, and I do that, it is simply, so what I got, it is 9, right? So it is 9 times I1 plus 3 times I2 is equals 42. Now I have to subtract this one. It is 2 times I1 plus 3 times I2 is equals 7, and I am making the subtraction like this. And I do that, this becomes 7I1, and this is 0, so this is 35. Otherwise I write I1 is equals 5 amps. the value of I1 I obtained 5 amps, right? So 5 amps is the current which is flowing here in the same direction. Now using this in equation 2 or 1, whatever it is, so now from 2, okay, so what I have to put, 2 into I1, 2 into I1 is 10 plus 3 I2 is equals 7. Otherwise I write 3 times I2 is equals minus 3, or simply I may say I2 is equals minus 1 amps. The significance of the negative sign here says the direction of I2 what we have considered is reverse. That means the current I2 is flowing in opposite direction. Okay, so in opposite direction the actual flow of current I2 is there. Well, so I am interested about the terminals A and B because I have to find the potential difference across the terminals A and B. Okay, so now potential difference across terminals A and B is equals, it is the resistance into the current I1 plus I2. So how much is the resistance in that branch AB? So the resistance is 2 ohm, and when it is multiplied by the currents, I1 is 5 amps and I2 is minus 1 amp. So the result is 2 into 4, which is 8 volt. So this is the answer. Okay, the potential difference between the terminals A and B is how much? 8 volt. This is the answer. Well, this is the first method what I have to tell you. So now I am telling the second method, which is called Thevenin's theorem. So for that I am using this picture. Okay, so the second, which is Thevenin's theorem. Thevenin's theorem. Here I am using this loop like this. First step is remove load resistance, that is 2 ohm. Right. So when I do that, the circuit may appear like this. This is the battery of 28 volt. It is as it is, and this is 4 ohm. Is also as it is, and on this side it is a how much? 1 ohm, and the battery of 7 volt is still there. The two are connected like this. So the two terminals A and B are also there, but there is no resistance in between. This is how I have to write. And here what I have to do is I have to find the potential difference between the terminals A and B. Okay, so then find potential difference between terminals A and B. That should be done. For that I use a simple technique, right? So I find how much current is flowing here. So the current should be found first. The current in the circuit is equal to what I can do, the effect of this to EMF 28 minus 7 divided by the two resistors are in a series, that is 5. Okay, so this becomes how much? It is 21 divided by 5 amps. This much current is flowing. Otherwise, if you want the number, definitely it is 5 means it is right, 4.2 amps. This much current is flowing in the circuit. Okay, so that means the current is flowing like this. Current is flowing upward. The potential difference across 4 ohm is equal to 4 into 4.2. Right. So this will be how much it should be? It should be, right? It is 8 and it is 16.8 volt should be there in between. Right. So here it is 28 volt at this point, and when I go to this point, that is nothing but A. Okay. So what I have to do? I have to subtract like this, 28.0 and 16.8. So this becomes, this is 2, and how much it is? It is 11 means 1, and here also 1. Right. So 11.2 volt is here, this point. Okay, so this is 11.2 volt. This point at this point are at the same potential, and since here it is at zero potential, the lower end, B is at a zero potential. Okay, therefore potential difference between the terminals A and B is equal to, it is 11.2 volt minus 0 volt. So this is equal to what? It is simply 11.2 volt. This is Thevenin voltage. Thevenin voltage or EMF. Okay, so this one. And now what I have to do is, I have to think about the second step where I short all batteries. Short all batteries and find resistance between A and B. In that situation, I may rewrite this picture in this manner. Right, this is point A and this is point B, this is 4 ohm and this is 1 ohm. So here resistors are parallel. Right, so resistors are parallel. So when the resistors are parallel, what I can do is the parallel resistor R1 R2 divided by R1 plus R2. Therefore, the effective parallel resistance here becomes, it is 4 into 1 divided by 4 plus 1. This is 4 divided by 5 ohm. Otherwise, I may simply say 0.8 ohm. So 0.8 ohm will be the effective resistance between these 2 points, right? So 0.8 ohm is the effective resistance between those 2 points, and the effective potential difference between these 2 points is 11.2 volt. So Thevenin equivalent can be written equivalent. How I write? Here is the EMF source, okay, and a series resistance should be considered, and still the points A and B are here. This is how I have to write Thevenin equivalent. This battery should be of this much potential, which is 11.2, and this resistance should be have this much a resistance, which is 0.8 ohm. And now I am connecting my load resistance here. How much is the load resistance? That is the resistance between these 2 points given. So that is 2 ohm. This is load resistance. Okay, so 2 ohm should be written here. And now I have to find out the current that is flowing here in this circuit. Right, so current is equal to, what I have to do, it is 11.2 is the EMF, only one EMF, divided by the sum of these 2 resistance. It is how much? 2.8 ohm, right? 2.8 ohm is simply what I can do is, it is 112 divided by, it is 28. How much I may get? It is when I divide it by 2, it is 56, right? It is 56 divided by 14. Otherwise, I may say when I divide it by 2, it is 2 2s are 28 and divide by 7. 28 by 7 means it's 4 amps. So 4 amps is the current that is flowing here. Okay, so when 4 amps current is flowing in this circuit, the potential difference between the 2 ends, nothing but the potential difference between AB is, therefore potential difference for 2 ohm resistor is equal to 4 into 2, this is equals 8 volt, right? So 8 volt, this is nothing but the E is the potential difference, right? E is the potential difference across terminals A and B, is what they asked in the question. And in both methods we got the same answer, 8 volt, and here also we got 8 volt.